He is known for his contributions to mathematical logic and abstract algebra. He is recognized for his research on the algebra of logic and integral solutions to algebraic equations. He is Thoralf Skolem. Thoralf Skolem, a brilliant mathematician and philosopher, was born into a family of farmers in Norway. Despite his humble beginnings, Skolem's passion for learning led him on a remarkable journey. After completing his secondary education, he enrolled at Det Kongelige Frederiks Universitet to study mathematics, immersing himself in various scientific disciplines along the way. Skolem's early career was marked by his collaboration with physicist Christian Birkeland, conducting experiments on magnetized spheres and aurora-like effects. However, it was in mathematics that Skolem truly excelled. He traveled to the University of Göttingen, a renowned center for mathematical logic and abstract algebra, and returned to Norway as a research fellow. In 1926, Skolem submitted his groundbreaking thesis on integral solutions to algebraic equations and inequalities. Despite his initial skepticism about pursuing a PhD, Skolem recognized its value and formalized his candidacy. Throughout his career, he held various positions in academia, teaching graduate courses in algebra and number theory. Skolem's influence extended beyond the classroom, as he served as the president of the Norwegian Mathematical Society and played a crucial role in establishing prestigious mathematical journals. Skolem's contributions to mathematics and philosophy were not limited to Norway. He traveled to the United States, sharing his knowledge and expertise with universities and scholars. Despite his retirement, Skolem remained intellectually engaged until his untimely passing. Thoralf Skolem's legacy as a brilliant mathematician, philosopher, and teacher endures, inspiring generations of thinkers to explore the intricate world of logic and abstract mathematics. His remarkable journey from a farming family to the forefront of mathematical research is a testament to the power of determination and intellectual curiosity. In his illustrious career, Thoralf Skolem made groundbreaking contributions to various branches of mathematics, including set theory, mathematical logic, and lattice theory. Despite publishing most of his work in Norwegian journals with limited international circulation, his ideas and theorems have had a lasting impact on the field. Skolem's interest in lattice theory led him to become one of the first mathematicians to write extensively on the subject. In 1912, he described the concept of a free distributive lattice generated by a fixed number of elements, a significant advancement at the time. He later demonstrated that every implicative lattice is distributive, and conversely, every finite distributive lattice is implicative. Skolem's work in lattice theory was so influential that he published a comprehensive survey of his earlier findings in a 1936 paper titled Über gewisse Verband oder Lattices, on certain structures, or lattices. Skolem's contributions to model theory were equally significant. In 1920, he simplified a theorem originally proved by Leopold Leuwenheim in 1915, resulting in the Lowenheim-Skolem theorem. This theorem states that if a countable first-order theory has an infinite model, then it also has a countable model. Skolem's proof initially relied on the axiom of choice but later incorporated Koenig's lemma as an alternative. His work on non-standard models of arithmetic and set theory further solidified his status as a pioneer in model theory. Additionally, Skolem refined the axioms for set theory proposed by Ernst Zermelo, introducing the concept of a definite property that could be encoded in first-order logic. This refined axiom, now an integral component of standard set theory, addressed the vagueness of Zermelo's original formulation. Notably, Skolem also identified what is now known as Skolem's paradox, which arises from the Lowenheim-Skolem theorem. The paradox suggests that if Zermelo's axioms are consistent, they must be satisfiable within a countable domain, despite proving the existence of uncountable sets. Skolem's remarkable mathematical insights have had far-reaching implications, shaping the field of mathematics and inspiring countless researchers. His work in lattice theory, model theory, and set theory continues to provide a solid foundation for further exploration and understanding of these fundamental mathematical concepts. Thoralf Skolem, a prominent mathematician and logician, had a unique perspective on the concept of infinity. He distrusted the completed infinite and was one of the founders of finitism in mathematics. Skolem believed that avoiding the paradoxes associated with the infinite was crucial, and he developed a system called primitive recursive arithmetic to achieve this. In his system, Skolem defined objects through primitive recursion, a process that allowed him to build the arithmetic of natural numbers. But he didn't stop there. Skolem devised another system, a programming logic, to prove properties about the objects defined in the first system. This groundbreaking work laid the foundation for a significant contribution to the theory of computable functions. Skolem's approach to defining objects and proving properties can be seen as an early version of a programming language and programming logic, respectively. Little did Skolem know that he was inadvertently paving the way for theoretical computer science, a field that would revolutionize our understanding of computation. Skolem's accomplishments didn't go unnoticed. Hao Wang, a renowned computer scientist, praised Skolem's work, recognizing its significance and impact. Skolem's primitive recursive arithmetic and his contributions to the theory of computable functions were groundbreaking and set the stage for future developments in mathematics and computer science.
Do you want to explore more philosophers? Who do you want to see featured next? Subscribe and leave a comment below to let me know. I'll see you in the next video.